Hello, everyone, and welcome to the Future of Space. I'm your host, Daniel Fox. Our guest today is Dr. Alan Stern. Alan is a flown commercial astronaut, planetary scientist, space program executive, aerospace consultant, speaker, and author. He has explored the wreck of the RMS Titanic and leads NASA's 1 billion New Horizons mission that explored the Pluto system and is now exploring the Kuiper Belt, the farthest exploration in the history of humankind. He has twice been named to the Time 100. Dr. Allen, welcome to the Future Space.
Thank you, Daniel. It's a pleasure. I'm looking forward to speaking today.
Well, I'm looking forward to hear about your journey of exploration and what led you to the depth of the seas and your love of space. But before we go there, what would be 3 words that captures the essence of space for you?
Well, I have to say, I'm either going to break your rules or that I've failed because I could only get it down to 4 words, and that is exploration at its greatest.
And with space always like a fascination and an attraction for you?
Yeah, as a matter of fact, ever since I was a little boy, it's all I ever wanted to do. I don't remember ever wanting to do anything else. My parents were very concerned. uh, I think my mom used to say something like, buddy, there's a fine line between in the groove and just stuck in a rut.
I mean, do you recall like certain moments that define that love or that fascination? Watching something on TV. I mean, I was walking, talking to Michael Massimino, talking about how obviously watching the landing on the moon, like these moments that define even Scott Hubbard, talking like saying that like at 10 years old he knew he wanted to be in space or about space. But so for you, can you look back and find those key moments?
Well, I can't find, I've thought about that, and I don't know what the genesis moment was, but I do remember um, having already been interested in astronomy and space for some years, how epic and pivotal watching the moon landings as a little boy was, and just thinking, I have to be a part of something like that. How do I grow up and be those people in some way?
Did you think like in that journey that space was, a kind of a destination to explore, or did you have the understanding that space was the continuation of where we're going, and then one day we will live in space?
I think both. Thinking back to the way I thought of it before I was in the profession, when I was just a child and then an adolescent and even a student, at university, I thought of both those things, and I don't think that I think they're mutually supportive.
Good segue to the second questions I always ask. There's we I think that people are always familiar with the science story of space, the technology story of space. Now we're there's obviously the politics, the legality, the legislation of it. But what would be like more meta? What would be the human story of going to space?
Well, I think there are lots of human stories, and most of them are probably unwritten because the great future of space exploration is largely in front of us, not behind us or even upon us yet. But I think of it as the most pivotal space, as the most pivotal inflection point uh, in the history of humankind, that really our emerging into space, to borrow a phrase from an Arthur C. Clarke story, is childhood's end and the beginning of our becoming a very different species, um, with many benefits.
I wrote this piece about how, from the perspective, not that I want to give the planet or life a personality or an entity, but if you look at the dynamics and the forces of life that's been growing in complexity for billions of years, it would be a shame to be stuck on this tiny speck, in the grand scale of the universe. If you're going to develop that much, and if you're going to invest in the evolution, ultimately so that it can continue, right? And from that we know of, we're the first species on this planet that now is giving life this opportunity to go beyond. So when life on this planet went from single cell to multi-cell, evolution exploded. Now about to go from single planet to multi-planet, and I have a feeling that evolution will just explode. Do you have that same kind of um, feeling?
I do. I think you're absolutely correct, and I think that that's an inevitable destiny of the fact that we are almost certainly the only species that this planet has ever developed that's looked up at the sky in wonder, and that has uh, an exploration ethic within itself that is a species which is one of, has exploration as one of our hallmarks. Of course, dogs and cats and many other animals, they're interested in their environment, and they'll explore in the sense of following something interesting, whether it's a smell or something they're chasing or what have you. But the raw sense of looking up and saying, what is that up there, and how do I determine more about it? How do I learn about our place? Even to appreciate that there is a universe is entirely uniquely human on our planet.
Yeah, I'm not too sure that elephants are gathering around a fireplace or on the Friday evening, contemplating about the big questions of the universe and what's beyond the horizons or what's happening up in the stars. This is definitely, who we are as a species, and I think that I've had several times I've had the question asked about the human nature of exploration, and I think that my understanding of it is that we've been able to create a story a, around life's force, right? Life, the constant evolution. That's because it's not this this the this exploration is just not unique to humans, right? Every organism will move forward and continuously move forward until they can't anymore. But what we've done as a species is we've created a story around it and we've engineered our way forward, and so we're almost kind of the best embodiment of life, always figuring out how we can go beyond the horizon, and space now is that new destination. Did you ever think that we would get there?
Well, if you say that we're all about new horizons, I guess I have to say I'm all about new horizons. But get where?
No, but to space, to that place where now the technology has is allowing us to really understand and to to plan the future, where now this is no more science fiction. This is actually a reality.
Yeah, well, just speaking for myself and the time that I grew up in, of course, I thought that we would get here. In fact, I thought we would get here a lot sooner on a different road, but we took sort of a 30 or 40-year detour between the birth of space exploration and the flowering of a space exploration that we now see.
And you've been to space, but you've also been to the Titanic. How different were those experiences? And is one harder than the other? I mean, I know the answer, but from your perspective, how different were they?
Well, they certainly share some commonalities, but they were very different experiences. Uh, uh, Descending to the Titanic was a very gentle process, uh, long and drawn out. In my case, the space flight was riotous and brief. And Of course, the Titanic came with it, seeing human artifacts and thinking about everything from the social injustice of the poor people being the majority of those who perished, uh, to just the arrogance of the White Star Line and its executive leadership in building the Titanic and allowing it to sail without enough lifeboats to handle a disaster. Um, Whereas spaceflight for me was about seeing our planet for the first time as a planet, and by coming home to a place I'd never been before. a place that felt not alien, as William Shatner thought of it, but actually a place that felt very, very peaceful and very comfortable. And I look forward to going back, in fact, again and again.
So what was your the first thought of or the feeling when you looked at the planet from up there? Um, some have experienced the overview effect. Some have looked at it with, different. I was just talking to Catherine Thornton, who when she looked when looked at the planet Earth, she didn't see the fragility of the planet. She saw the fragility of her species, but she saw a planet that was extremely resilient, who was there before us and would be there after us. So, what was your experience of looking at the planet from up above?
Well, for your audience, I have to say as context that I flew to space last year as a researcher. That meant that I had a pretty heavily scripted and very tight timeline. So I wasn't able to just plaster my face in the window and take it in the way that a lot of tourists are able to. I'm a little jealous of that. But nonetheless, I had a number of opportunities to look out the window. And I remember the first thing that came to my mind, and it was that uh, the planet is vast. And that's the word that came to my mind, vast. Because for the first time, I could see a half a continent and the ocean beyond it, all in one view. Very different from what you see from an airplane, in which you see kind of a little postage stamp view of some place on the earth, and you're so low that everything is flat and two-dimensional. You're too high to see the relief in most cases of trees or buildings sticking up when you're at, say, 40,000 feet in an airline. When you're at 300,000 feet on a suborbital space flight, you see the curvature of the Earth. It's impossible to ignore it. And you see, at least in our case, mountain ranges below us in miniature, stretching off across the entire western half of North America to the Pacific. Spectacular.
Many look back and they see, well, the unity, right? And all these people, they don't see any frontiers. But from my perspective, often is that perspective allows you to see even more different realities, right? I think we have to recognize that the mountains are different than the oceans. All these different locations create different realities to people. So to recognize all these different stories so that we can move forward. And as we go to space, there's going to be different stories also, right? The moon ultimately will be different than Earth, and the people from orbital stations will be different. And if we can, first of all, recognize those differences so that we can come to the table understanding where people are coming from so that, we can move forward. Do you see the challenges? Are you fully aware of the challenges as we move into space, how these different realities will come into play?
I certainly understand what you're saying, and I agree with it. And I think that those are some of the predictable outcomes of our moving into being a spacefaring and even space inhabiting species. But I think that there are going to be unintended outcomes, some good and some bad. And when I say unintended, things that we can't predict today that may come from the isolation, from the remoteness, or from the discoveries that people make. The same thing happened when humans began to explore the Earth in 15th century. As a result of that, they started to realize they were on a planet, but they also could not predict that the outcome of their exploration would yield things as diverse or maybe as unexpected as the real flowering of worldwide society and of democracy. This all came from the fact that really setting up shop on another continent made it difficult for the homeland to be overlords. Now, I don't know that we'll have a similar political and sociological kind of revolution, but I expect that we'll have things that we just completely don't expect, that people 1,000 years from now will look back in hindsight and say it was pretty obvious, the way it turned out, but that you and I, stuck in the early 21st century, can't imagine, unfortunately.
Yeah, we have to be careful how we judge the past, because if because we will be judged by the future, in the same manner. And, North America, you look at the ocean exploration. Well, what drove a lot of the ocean exploration was how messed up Europe was. They had driven their resources to a brink of collapse. All the trees were cut. Now it was the kings and queens were funding these exploration, but it was resource driven. And North America was not the destination, right? It was Asia, it was the spice route. And in the process, North America was, discovered to be the new land of opportunity. But so many, you look at scurvy, who they did not know until it happened. But I have a feeling that the human cost of exploration or seeking knowledge will never be what it was, because now we have the capacity to know a lot more before. We have drones up, on Mars. We have a drone on Mars. We have rovers on different planets. You have your own mission, which I want to know more about New Horizons. So by the time we go there, we're going there equipped with a lot more information. But tell us about the New Horizon. What are you looking in Pluto and the Kuiper Belt? What are the objectives?
Yeah, very succinctly, when most of us went to school, the map of the solar system was very different than it is today. It was not until the 1990s that the Kuiper Belt, which is the third zone, the farthest zone of our planetary system, was even discovered. And Pluto was kind of a harbinger of that, but now we know that the Kuiper Belt is teeming with small relic objects from the era of planetary formation with a lot to teach us, and also teeming with small planets like Pluto, that we didn't know existed. And so it's really, in a sense, the frontier of our solar system, and a little bit the Wild West, the most bizarre region. New Horizons is the first spacecraft sent to explore that region. In 2015, after a 10-year journey at very high speed, it reached the Kuiper Belt and near its inner edge flew by Pluto and its system of moons in the summer of 2015, and returned all the data from that in the following year, and then went on to make the first exploration of Kuiper Belt objects, which we continue to do today. In fact, we're discovering the Kuiper Belt probably stretches quite a bit further than we expected, so that we won't leave the Kuiper Belt in the middle of the 2020s, but perhaps only in the 2030s. So we have a lot more exploring to do, and the spacecraft is fully capable of that. It's perfectly healthy, and it's got the power and fuel to run probably till 2050. So it's just a dream come true to be a part of a mission like this for all of us involved. And I'm looking forward to what we find next that's unexpected and that teaches us more about our home solar system.
So, for the record, Pluto is a planet?
Well, of course it's a planet. Take a look at it.
And do you think that is it the planet 9, or there's like another planet which would be more like on a different orbit, like a funny orbit, more elliptical?
So several things to say there. First, we've already found planet 9. New Horizons flew by it. That's Pluto. Second, there's very good scientific reason to expect that we will discover many more planets in our solar system farther out. It's very hard to do. The current preponderance of evidence is that the Brown and Madigan conjecture of a planet in a specific direction has turned out to come up empty-handed. But I expect that we'll find many more planets. We're already finding small planets across the Kuiper Belt, and I expect that we'll find Mars-sized and Earth-sized worlds, and maybe even larger, farther out in the Oort cloud, for example.
And so what defines, Alan, the Kuiper Belt?
Well, the Kuiper Belt is a region beyond the planet Neptune that's characterized by a large number of dwarf planets, meaning small planets, the size of continents, but perfectly round and the kind of thing that the Starship showed up at and turned on the viewfinder. You'd say, oh, they just reached some alien planet. And even larger number of primordial relics of the era of planet formation. And because it's so far from the sun, It's very cold out there, and the cold acts as a deep freeze that preserves the chemistry and the physical conditions at the birth of our solar system. So it's a scientific wonderland. It's a resource wonderland. It's a region that may be teeming with biology in the subterranean oceans of the dwarf planets like Pluto. We'll have to find that out through missions that succeed after New Horizons to tell us more and more about these worlds.
So now New Horizon is on a linear path beyond the Kuiper Belt, or is it at one point kind of is it like moving, in and out through that region?
So New Horizons is traveling very fast, so fast that it's on a straight line trajectory that is escaping our solar system like the Voyagers. And so long after it runs out of power and can no longer communicate, the derelict New Horizons will emerge out of our solar system and into the larger galaxy. Now, we expect that before it runs out of power that we'll reach interstellar space as defined by the sun's heliopause and when we're on the other side of that. That may come as early as the early 2030s, so the late 2030s, but long before the spacecraft runs out of power. But New Horizons is not coming back. It's not trapped in orbit around the sun. Like the Voyagers, it's escaping.
So that would be the third spacecraft to escape, to go beyond our solar system, correct?
It depends upon how you count it. First, there were two spacecraft, Pioneers 10 and 11, that preceded the Voyagers. And so that makes five. The two Pioneers, the two Voyagers, and New Horizons. But interestingly, each of those five also had its uppermost rocket stage that traveled fast enough to also be on escape trajectories. And those, of course, never communicated with us or sent pictures. They weren't equipped to do those things. They died typically on batteries the day of the launch, but they still left the solar system. So depending on how you count it, there's either 5 or there's 10.
Really? Well, I never thought about it. But do we keep track? Do we know where they are, or?
We know approximately where they are. For the ones we can track, like New Horizons, we know precisely where it is. Same for the Voyagers. But after we lose contact with them, we know less and less about their trajectories because we are not able to track them. So we know generally where they're headed and their speed and their distance, but we don't know precisely where they are.
Never thought about it this way. Alan, when you talk about, I mean, for a lot of people and even myself, sometimes when we think of the difference between moon and planet, we think of it's a question of size. But it's not. So when we're in a Kuiper Belt and we're talking about planets that are the size of a continent, what makes these objects, these celestial, a planet rather than a piece of rock or a moon?
Yeah, that's a great question, and it's been addressed scientifically and very precisely. So it's very simple. When objects are small, whether they are rocks or boulders or mountains or asteroids, for example, that are kilometers and tens of kilometers across, their shape is controlled by essentially the bonds within the minerals and the rocks. And the chemistry determines, the strength of the chemistry determines how the object is shaped. But as you make objects larger and larger, pile on more mass, eventually they cross a boundary where gravity overwhelms material strength. And as a result, all really large objects are rounded. Take a look at the Earth, Mars, Venus, all the planets that we've ever seen are rounded due to self-gravity. That doesn't mean they have to be perfectly round. They can have mountains on their surface and fissures and canyons. They can be a little oblate because they're rotating. Other effects can cause them to deviate, but the basic hallmark of planethood is when they become large enough to be big round balls due to gravity. Not due to being a soap bubble, that doesn't count as a planet, but when they're rounded due to gravity, they cross this barrier, and then they start to act in complex ways that geologists recognize as planets. They develop internal engines and geophysics that's much more complex than what we see in smaller bodies whose shape is regulated by only their material strength and perhaps their rotation. Of course, Not every round object in space, every gravitationally round object in space is a planet, because if you continue to pour on mass, the temperature in the interior, due to that mass acting compressively, acts to raise the central temperature. The Earth has a molten interior. But as you in bigger and bigger planets, the central temperature is higher and higher because they have more and more mass, and that compresses the interior and creates that temperature. Eventually, when there's enough mass, the central temperature is large enough to ignite nuclear fusion in the interior. And those objects that do that are no longer called planets. They're called stars. They emit light like the sun does. And they're round for the same reason, because gravity has overwhelmed the material strength. But they now are generating prodigious amounts of energy through fusion processes. And we call those stars and not planets. So planets are trapped between the smallest round things and the biggest round things that do not do fusion. And that's a very wide range in mass. It corresponds to objects as small as about 1/10 of Pluto's diameter, of which there are many in our solar system, up to objects more than 10 times the mass of Jupiter. So there are several orders of magnitude in that, just as there are several orders of magnitude in the masses of stars as well. But that's how we define planets: objects that are in space, large enough to be rounded by their self-gravity, but not so massive that they ignite fusion in their interiors.
And the moon is a planet, or a moon? A moon is a planet that circles another celestial? Is that what the definition would be of a moon?
Well, in planetary science, we're coming to appreciate that an object is a planet independent of where it is, what it orbits with. Even if it orbits another star, it doesn't have to. And that just like stars can orbit stars and asteroids orbit asteroids, galaxies orbit galaxies, planets can orbit planets. And so when that happens, the largest one is called the primary in a system where there are multiples. And then the others are called satellite planets. So Jupiter has a number of planet-sized worlds like Io and Europa and Ganymede and Callisto that orbit it. It's a 5-planet system, if you think of it that way. The Earth is a 2-planet system because the moon is large enough to be considered a planet by the geophysical planet definition. You go all the way out across the solar system. Pluto is a double planet with its very large moon Charon. So while we're not getting rid of the term moon or satellite, some moons are large enough to also be planets. And that's becoming an increasingly widely used lexicon.
I never thought of it, I never knew that stars were basically planets that, because of the size of it and the gravity, it ignites, right, that pressure, basically now it ignites. Do we know exactly what is that mass for that ignition to happen? Or that is still remains unknown?
No, it's very well known from nuclear physics. And the smallest objects that can ignite temporarily in nuclear fusion at a very low level are called brown dwarfs. They're about 13 times the mass of the planet Jupiter, or very roughly a few thousand times the mass of the Earth. That's the lower limit. The sun is much more massive than that, something approximately 1 million times the mass of the Earth. And there are still much larger stars that are tens of times more massive, maybe in the most extreme case, 100 times as massive as the sun.
It's always hard to try to grasp the size of the universe, not just in distance, but in quantities and in scale. Now we're capable of seeing remnants of light from 13 billion years ago. And these black holes that are the size of, of our solar system, or I don't know if it's that big, but what do you think when you think of the vastness of the universe?
Well, first, I can't comprehend it enough, given up trying, because it's a waste of time for me. I know that I just can't put my head around it. It's too much. But wouldn't it be, in many ways, a waste if the universe wasn't teeming with life, and that there weren't countless habitable worlds and all kinds of expressions of biology and species that are smarter, wiser, older, more experienced than we are, all across the universe. I guess that's my aspiration, that we would discover that, because we really don't know enough, other than the fact that there are so many trials in the trillions of stars, and we know that almost all stars we now know have planets around them. It would be very hard, at least for me, to comprehend that in all those experiments, if you will, of planetary evolution, that only the Earth came to have biology. But as a scientific fact, all we can do now is to look at the habitability of worlds where they are suitable for forms of life that we could understand. The biggest revolution, I think, in my career has been the complete upending of original sensibilities that habitable zones had to be close to their star, simply because our planet, which is habitable, is close to its star. We now appreciate that water oceans are common in our solar system and almost certainly common in others, far beneath the surface of planets. And in those ocean worlds, those oceans, which are liquid water oceans, might well be abodes for life in outer solar systems, even in planets that have been ejected from solar systems. And the realization that ocean worlds are common and that they can remain as liquid water ocean worlds, even in remote environments that are nowhere near their star, really opens up the possibilities for evolution of life and the discovery of life across the universe, I think.
Well, we didn't think that life would exist at the depth, in the ocean, and it's teeming with life of a different form. I think that our definition of what is needed for life constantly is being reassessed. But for me, there's one constant in that is it's not just about having the ingredients for life, but having an environment where these ingredients are constantly mixed. In one of my presentations that I made the analogy, with bread, how you can have the ingredients for making bread. You can have them on the counter and stare at them for thousands of years if you want to. Nothing is going to happen. But for bread to happen, you need to mix those great tension and disruptions, and then you have to let it rest for a little bit for, to rise. And then when it's time, then you have to put it in the oven, disrupting it again. And then, you have that bread. And I think that the reason why life on this planet has successfully become what it is, it's not just the ingredients, it's all these dynamics that are constantly mixing it, the differences of the seasons, the around the sun, the moon, with the tides. It's a dynamic, it's all the disruptive elements that are creating opportunities.
I agree with you. You can't have life without both those things, and you can't have bread without both those things. But it's also important to recognize that the environment and the stability of the environment is also important. In the case of bread, you can mix things the right way, but if the house is on fire, the bread's not going to last. And similarly, we've learned that, like for the Earth, which is a sort of precarious world in many ways, because the Earth is subject to bombardment by asteroids and comets and dangerous radiation events like supernova or mega flares on the sun. For worlds that where there are oceans on the outside and where the biota is on the outside, you have to really thread the needle over billions of years to not suffer one of these catastrophes. But for ocean worlds that are where the oceans are deep beneath the surface, they're protected from solar flares and supernovae and big impacts on the surface and many other hazards that we have to survive against, but they are insulated from. And it may be that those deep ocean worlds are better suited because of their environmental stability to give birth to biology.
I think we'll find that the universe is full of life, but the intelligent life, I think, is even more rare because we can look at even on our own planets, right? Had it not been for the randomness of the universe, for that giant rock asteroid to change the fate of the dinosaurs would still exist today, right? The dinosaurs existed for hundreds of millions. They could exist for hundreds of millions more. So life can exist for hundreds and millions of years, but for an intelligent or for a species that really separates itself from the rest and start inventing tools and creating things. That is a series of fortunate accidents that lead to this.
And then through deliberate action, I expect we'll become a multi-planet species and be still more resilient to these kinds of environmental or self-inflicted hazards to our existence, whether it's in climate change or a nuclear exchange or anything else bad that could really wipe us off one planet. Having our species um, populate the solar system will be a tremendous insurance policy against that.
And that it's the I always say that we're about to give life its biggest gift ever because we're about to give it a series of options that before didn't have it. And I don't like the idea of being at the mercy of the randomness of the nature. Alan, what is the next phase for New Horizons? Obviously now, I'm pretty sure that you're not one person who's satisfied with, now New Horizon doing what it is. I'm pretty sure that your mind is already on a series of other projects.
Well, I'm involved in a lot of other projects, but for New Horizons, we're continuing to explore the Kuiper Belt. We're looking for another flyby target, but it's a very tough problem and a bit of a needle in a haystack because we're low on fuel, and we need fuel to divert the trajectory to another object that we can get to. And we're looking forward to crossing the outer heliosphere into interstellar space, which is much more certain for the science that we'll be doing than finding another flyby target. But I can tell you there's no better team in the world than the New Horizons team. It's populated with very dedicated, hardworking people and the world's experts in searching for faint things in the outer solar system. So we're looking forward to between 20 and 30 more years of spacecraft operations. NASA has funded us through 2029. After that, we'll have to prove that we're productive and doing important science for NASA's dollar. But all missions have to do that from time to time. I think New Horizons has a very bright future.
That's for New Horizon. I still can't believe that you have a team or we're capable of looking at a spacecraft that is moving so far away and we can identify targets and where you can change the trajectory of the spacecraft that is moving so fast and still have it do a flyby of another object. It's incredible.
It's incredible. No other spacecraft that I'm aware of has, as New Horizons has, gone to objects that its team discovered after it was launched, objects that we didn't even know about at the time that the spacecraft was put in flight.
It's incredible. And the experiments that when you went up to space, you said that, you guys were doing experiments and you were really on a tight schedule. Everything was planned to the second. So what were those experiments?
The flight that I went on had two researchers and space tourists and an instructor, astronaut, and then a flight crew. So there were six of us on board. The two researchers were Kelly Girardi and myself, and she was doing some experiments in fundamental fluid mechanics and microgravity, and also she was doing some physiology measurements on herself. I was also doing a physiology experiment on myself in reaction to spaceflight, and then doing a training operation for my next spaceflight, which NASA is funding, in which I'll be carrying out some astronomical observations from the spacecraft in order to determine how well these new suborbital vehicles can do astronomy, because they're much less expensive than the old way we did suborbital science with sounding rockets. And if we can use them for astronomy, it'll be an important new tool in our toolkit. It won't replace the old way, but sort of like the fork, the knife, and the spoon at the table. They're not really in competition with one another. They're different tools that make different things possible. And I think new suborbital vehicles will make new things possible in the research area that we couldn't do before. And that's part of their exciting promise.
When is that flight? Is that flight scheduled and confirmed, or?
That flight is confirmed and it's funded and it's under contract, but we don't know when it will be. Our intent has been to fly it on Virgin Galactic, and you may know Virgin has now paused their flight operations to build a more sophisticated, newer generation vehicle, which they expect to come online in 2 years' time. And so I expect we'll be flying early in that flight sequence, but not before.
Well, I'm pretty sure you're anxious to go back to space and continue the experiment. And so,
Well, I guess I shouldn't say I was surprised, but I found that space flight is incredibly pleasurable, and even more than the pleasure I derived and I discovered in it, it's incredibly addictive. And almost everyone who's been wants to go back, and that's certainly the case for me. And I hope to have that opportunity not just one more time, but hopefully several.
several times. Alan, I want to be mindful of your time, and also I want to honor and respect your career and your knowledge and your experience. What would be Dr. Alan's 3 words of wisdom?
Daniel, my 3 words are these: always keep exploring.
And that's one thing that we need to reconnect ourselves with these new frontiers, right? I think that we've created such a negative narrative about the human species now, and we think that everything that we do as is worse than better. And like back in the days of Shackleton, there was an attraction to these stories, to these new places. Now, like I go, I'm bringing a bunch of people to Antarctica. I've been there several times. I keep saying that no, we need to go to Antarctica. We need to go to the moon. We need to experience these places. These destinations are always an important part of taking care of the solutions that we have on Earth, right?
I agree. I think we should explore not because our fear that others will explore if we don't, but because exploration is so powerfully expanding. It expands our horizons, gives us new opportunities, satisfies something important that makes us human species, but also opens new opportunities. And as I said, the exploration of the Americas brought the flowering of democracy. So the kind of benefits that you get from exploration aren't purely about the technology and the science at all. They're also very human. And I expect that as we flower, as our species flowers in terms of its spacefaring nature, that many good things will come for our society, for our economies, for our children and our descendants that we can't even imagine that come from this exploration. It's been true in every form of exploration humans have ever undertaken, and space is the biggest stage there possibly could be. So I'm very much an optimist.
And when people say we're not ready, we have things to take care of first. If we wait for this, nothing will ever get done, right? No, and like when you have children, you're never ready to have children. You have children, and then you figure it out. You're never ready for a job, really. You figure it out, and
I agree. When I was at the beginning of my career, I had a friend that told me once. He said, "Alan, you're waiting for all the shit in your life to be over, for it to somehow just become, smooth sailing." He said, "It's never going to happen. Get used to the fact that there are always going to be problems and new problems and important things you have to work on, solve, repair, adjust for." So I think the same is true in society. We can walk and chew gum at the same time. So we're a great society. We can solve our problems at home at the same time that we explore and find new ways forward. And I think it's important that we not be too inward, that we also look forward to the future.
Alan, it's been a pleasure. Thank you so very much for taking the time and for sharing your wisdom and all the knowledge. Much appreciated.
Thank you, Daniel. It's been a pleasure here too, and an honor, and really engaging. I appreciate it.
Well, looking forward for your next voyage up in space and all the wonderful things you will be accomplished with your team. So once again, thank you.
Thank you.